Hey folks, Emily here. Today you are going to learn how to train language models on AWS Trainium in single node mode. So we're going to use one instance to train our language models. Let's dive in. All right, so you've learned about the accelerators, you know you want to move your data faster, you know how the Neuron SDK works, you set up your development environment, and you ran inference using VLLM potentially with a couple language models. Now, we're going to take a look at another part of the stack called NeuronX Distributed Training. So remember, the basis of the stack is the same across both training and inference. You've got the neuron runtime, you have the neuron compiler that generates this NEF file format, and then you have PyTorch and PyTorch XLA that kicks off the neuron compiler to eventually send instructions to runtime. So NxDT core and PyTorch and the rest of the stack are the same. The compiler is the same, collectives are the same, the driver is the same, all of the rest of the stack is identical across both training and inference. NxDT core is also compatible with both training and inference. The difference is on top of that. So in inference, you remember we added support for inferencing modules like disaggregated prefill caching, like KV caching, like VLLM. And in training, we're going to add support for other libraries like the Hugging Face Trainer, like RayTrain, like PyTorch Lightning, and many capabilities in between. So NxDT operates with a YAML interface. You will pull down the NxDT library and use the YAML files to define different configurations for your base model, for your tensor parallel degrees, for your batch size, for the rest of your hyperparameters to modify how you're training this model. We have many pre-built training workflows. You can pre-train your own Llama models. You can pre-train your own BERT models. You can do supervised fine-tuning. You can do LoRa adapters and LoRa fine-tuning for more efficient training and then inference as well. And you can also do model alignment with DPO and GRPO type techniques. So all of those are pre-built for you and predefined within the NxDT library. You can use those through this YAML config and interface to easily execute the commands. And again, the reason why you want to do this is because we handle the compilation for you, we handle the interface to XLA, we manage how to invoke the runtime. All of that is managed for you below the NxDT interface. We also have many pre-built models that are available that you can use from the Model Hub. So again, dense models, MOE models, and multiple modalities. And so NxDT is a comprehensive library that you can use to fine-tune and pre-train your own language models on Trainium today. And so how do we do this? What are some of the key steps? So again, we're in single node mode, so you have one instance. And in one instance, as you remember, we launched the instance, we accessed the instance, we activated the virtual environment. This time you're going to activate the virtual environment for training, so NxDT. And your first step is going to be to ensure that you have a working build of NxDT. There are many packages, many pre-requirements. Your first step is to ensure that that is compatible. So you'll pull down the latest NxDT repository, you'll pull in other supported libraries that are necessary to ensure that the entire package is operational, and you'll set this up. That's step one. Step two is downloading the model. So you can download the model from the Hugging Face Hub, for example, and you'll actually convert that model to operate within the constructs of NxDT. And again, we have pre-built modules that you can use in order to do that conversion. Step three is to prepare your data set. Again, we have pre-built configurations and examples showing how to prepare your data set for the supported modules today. And then step four is to compile the script. So again, use our command to compile that script ahead of time and then train the model itself. And all 4 of those steps are available for you using NxDT across the various modes that we support for training. With that, let's check out the demo.
I'd like to demo Hugging Face Llama 3.1, Llama 3 8 billion parameter fine-tuning with LoRa on Trainium 132x large with the neuron SDK. Since this model is relatively small, it can fit on a single instance. To start, we first need to launch Trainium 132x large. So to launch that, we first start to give the instance a name. And then we need to choose the right army. When we choose the quickest one is to search the neuron, you will see there's a quick start army. There's the Amazon Linux system and Ubuntu system. Either one will work. In this demo, we will choose the Ubuntu one. After choosing the army, we will choose the instance type. We can choose the Trainium 132x large here. Because this is a relatively large instance, it has an option of using capacity block or not. We will use on demand, so choose the no capacity block, and then choose the key pair for login. And after that, we set the root volume for this 8 billion parameter model. 1 terabyte should be enough. And then click the launch instance. After you launch the instance, you can log into it and set the training environment as the first step. After you log in the Trainium 1 instance, you can activate the virtual environment. The virtual environment is pre-built. Use this command. And then you can follow the step in the documentation, set the virtual environment. One key step is to install the NxDT correctly. So we already have the virtual environment set up, and we already have the dependencies set up, but we need to have this Apex repo set up. We clone the Apex repo and check out to the right branch. This will take some time. Right now we are inside the Apex repo. We will replace the setup file with the one that is neuron specific. Okay, replace this one, and then we can follow here. We can install this packaging and wheel file, and then build the wheel with the command. And then build the file with the setup file that we just edited. Now the build complete. We can see there's a dist directory is generated. There's a binary of the wheel file is there. And then we can go outside this Apex directory and download another dependency that is the requirements .txt from the Nx distributed library. After download that, we can install the requirements and just build a wheel file in the requirements and the wheel file. Make sure you have the Python installed. And then you can install the requirements and the newly built Apex wheel file. And after that being installed, we will need to patch some installation to the neural X distributed master run. Yeah, we copied the XD patch installation. Right now we install that. This could take a few minutes. After this step, our environment setup is complete. Okay, we are done. We can check the neural library right now. Yeah, looks good. Environment setup. The third step is to download the dataset and the model JSON file. To download the dataset, so we actually already pre-processed the data and saved that in the neuron S3 buckets. So you can see this is downloaded already. So right now we are in the Llama 3 the folder, Llama 3 8B folder. After download that, we can download the tokenizer, the JSON file. Dataset, the next step is to download the checkpoint and the tokenizer. So we can use this example script to download it. Tokenizer. Just needed to be like a one dependency is this meta Llama 3 model is gated model. So before you start downloading, make sure you have the token Hugging Face token ID available and have that in your environment. And the model weight is downloaded completely. Let's take a look. Yes, you can see this is the weight, this is the tokenizer folder. Next step, we need to convert those tokenize the weight that is in the Hugging Face format to the format that could be accepted by the Neural X distributed library. But to do that conversion, we need to find the exact config file we are going to train. Then we can do the conversion. So the conversion script is available in the Neural X distributed library and the example directory. You can see this is the script. It provides different kind of conversion. It could be from like Hugging Face checkpoint or from Nemo Megatron checkpoint. And if we look at the config file, right now we are going to do the Llama 3B LoRa fine-tuning. We need to check this YAML file. In this YAML file, it has a different setup, especially those hyperparameters are important for the conversion is the linear, like the keyway linear, how many the TP, PP, those information. So we needed to do the conversion, set up the checkpoint conversion flag. So for example, the keyway replicator. So according to this, like these hyperparameters. about the checkpoint conversion, you can look into this tutorial website, and you can follow the checkpoint conversion guidance to figure out exactly what needed to be specified and the detailed run command depending the configuration file and your existing checkpoint format. So here, so we already started the config file, and we can do the conversion now. Go to the checkpoint conversion script directory, and then we can use the commands like right now we have this the checkpoint conversion format, and we have the model format is meta 3 8b Llama 3 8b, and we have this output pre-checkpoint saved in this directory, and the configuration file, we needed to specify it to the right one, and the TP, we saw that 32 pp is equal to 1. The number of layers need to match the configuration file, and also we wanted to set the convert from the false state. Okay, so the checkpoint conversion is completed now. So as you can see, after the conversion, you will see the distributed checkpoint being saved the defined pre-checkpoint directory. Right now, so after you have that directory set up, we need to confirm the config file, the directory being set correctly before we start compile and train the model. There are the 4 points you need to confirm. First, the checkpoint, that is the right directory. Second, the training directory for the training data that we downloaded in the step 3. And also the validation data points, and also the tokenizer we downloaded in the step 4. All of this needed to be set up correctly. And finally, we make sure the model configuration file, the config.json, is set in the correct directory. After that setup, we should be ready to start train the model. Start the training process. Before the official training, we need to compile the model first. To compile the model, we need to go to the NeuralX distributed training examples directory. In this directory, you can see there are files about train.sh, train setup.sh, training orchestrator.py file, and training.py. So let's look at these 4 files. So in the train.sh, so basically, it will call the train setup.sh, and it's set up the configuration file path, and also the distributed nodes, like how many instances you're going to use, each instance, how many workers you are going to set up, and also it specifies if it is a compilation mode or not. So as you can see in this file, it will use the torch run command to call this training orchestrator.py. So let's look at the train.setup first. So the train.setup. So in this file, you can see it defines all the distributed flags, like the global word size, like how many total number of the workers, and also we are using the Slurm node if you want to do the distributed training. And also we specify the EFA configuration, and also define the login path. So, and also like the checkpoint callback, all of that, like high level flags. And for the training script, so first let's look at this training orchestration file. In this training file, it defines some hyperparameters like the data type, like right now we could define the Excel use BF16 and also the compilation flags. So those kind of still kind of high level parameters, not specific to the training like a specific training workload. So this could be universal to different training workload on neuron. And the real training script is named the training.py that is going to do the real fine-tuning that we specified for this Llama 3.8B model with LoRa technique. So it calls this trainer.fit. This is the real the training loop where it happens. So before that, you can see it defines the configuration type and also the data loading, those kind of prep work. So this is defined in the training loop. Okay, so since we are going to do the compilation, we wanted to set the compilation flag as equal to 1, and then we can launch this train.sh run command. So it will start the compilation. The compilation could take about 10 minutes ish. So depends on how big your workload is. Okay, the compilation is completed right now. Just want one thing to remind you, when you to try to compile, make sure you have this configuration file being set to the right model config. Otherwise, you will miss exactly which model you are trying to compile. It might run into errors. After this compilation complication, we can launch the real full training right now. So make sure set the compilation flag equal to 0 and then exactly launch the train.sh. So this will start the full training it will be run much longer than the compilation, and also you can check the final checkpoint saving to the end. Okay, so maybe I can leave this on a few more minutes, and then we saw after we seeing the first epoch, the iteration shows up, we can stop the demo. This part is trying to load the cached NAF file from the pre-compiled directory. Okay, so the training officially started. You can see the throughput, the loss value, and also the steps right now. So I think I will stop here. So if you have any questions, please contact us, let us know.
All right, thank you, John Yang. I hope you enjoyed learning how to fine tune and train your own language models on NxDT. Quick call to action again, we have many models that are well supported today, from documentation, samples across a wide variety of models, capabilities, and features. So biggest call to action is just to go check them out. We have lots that are well supported today. Again, NxDT and Hugging Face Optimum Neuron are excellent libraries for you to get started with fine-tuning and testing models for training today. And so with that, again, a big thank you to the team. It is not possible to develop and maintain libraries without A+ engineers who help us do this. So just a giant thank you to the whole team who makes this possible. And so with that, I'll see you in the next video.